I mean, I get it. You've never written a unit test before. Everybody says it takes so much time and that it's boring. It's not your fault. But automated tests are king when it comes to building reliable software. No idea what I'm talking about? Say you have an old app in C# and you are afraid to touch it because you have no idea what will break and what not. The app relies on a couple of SQL databases, maybe a message broker, and you are thinking there is no way I can test this at all, and my boss won't ever pay for additional databases. Well, fear not, my friend, let me show you how to set up your very own test environment in code. Yep, you won't need to leave Visual Studio at all. This method uses Docker, but don't worry, you won't need to use Docker directly. Everything will be handled for you by a NUgget package called test containers. Look at this code, for example. This code works like magic. It starts a brand new Microsoft SQL server for you. Yep, just like that. No need to install anything, no need to worry about the setup, it just works. And the bottom line sets up the database schema exactly like your production setup, so you can very easily configure your app to use your local database instead of your production environment. This database is completely isolated, so we won't ever break anything, and it's a full-blown SQL server, so your existing code will treat it like it's connecting to a production instance. Excited yet? I know I was when I first saw this. So without further ado, let's look at how you can make this work for your case as well. I will assume your solution looks something like this. There is your current project, maybe you have a couple of them, doesn't really matter. Let's go ahead and add a new project. It will be a unit test project, and yes, I will be using MSTest for all of you haters out there. Click next and name your project exactly the same as your main project, but add the .tests at the end. Visual Studio will create a new test file for you and you can run it. For that, you will need the Test Explorer. If you don't see it yet, click on View and then Test Explorer. Here you will see all your tests as you write them, and your overall goal is to make all those tests produce nice green check marks. That's your prize. But you still need to earn it. To run all the tests at once, click this green play button. You can run a single test as well by either right-clicking on the test and selecting Run, but there's an even better way. Just find the test method and click on the small icon above public. Perfect. Now, at this moment, your test doesn't really do much. Let's actually implement the test now. Write the name of the method you want to test, then let Visual Studio figure out how to import your other project into this new one. Before testing the whole app and setting up the database, let's first write a simple unit test for one of our methods. And the goal of these tests is to ensure that when you run a function with one set of parameters, it should return a desired result. Usually the tests are made up of three parts. The setup stage, where you prepare your data and the test records you want to run your function with. Then we have the act stage, where you actually run the method. And in my case, this is a simple method which only performs some calculations and it has no internal dependencies. It doesn't connect to any external databases, so I'm really only interested in its outputs. And that output is being checked in the third stage, which can be called assess or assert or verify, or I'm not really sure, but that's how I like to call it. So in this third stage, I'll use a C# API called assert. Assert talks to the test environment and reports any failed checks. It's really simple to use. If you want to check if the result is equal to something, just type assert.requal. And you can also use is true or is false. You can check if your method throws an exception. It's really simple and it's effective. Looks like I've made a mistake somewhere. My test failed, but no worries. I'll set up a breakpoint here at the beginning and just debug my test. And now I can see exactly where it failed and I can fix my code. Brilliant. Now I have my check mark and it's legit. What I just showed you is how to write a unit test. I tested a unit, a piece of code which doesn't interact with any outside component. Let's step up our game and write an E2E test now. This is where Docker comes into play. The function that I just called is actually being called by another function, which receives an SQL connection string, establishes a connection, retrieves some records, and then writes the results back to the database. Easy. But how to unit test this method? How do I make sure that the records are actually being written back to the database if I don't actually have the database? Well, say no more. Let's make ourselves a brand new Microsoft SQL database, right here in code without any additional Docker stuff. For this, I'll be using a NUgget package called test containers. Well, I could write the code to run the Docker myself, and I could then make sure that I clean up everything after use. Test Containers does it all for me. To get started, I'll right-click on my test project and click on Manage NuGet Packages. Make sure you are on the Browse tab and search for testcontainers.msSQL. Install this package. It might take some time to install, but after it's done, go back to your test class and do the following changes. First, make a new field called _database container. Then make a new method called class initialize. So public static async task class initialize, and then for the parameters use test context. Also, make sure to annotate the method with the class initialize attribute. This will make sure that the logic only runs once before all other tests. Great. Now, moving on to the actual code. We need to start our database. We need to initialize our field, so type _database container equals new MSSQL builder. Let's specify the password for the SQL admin. Just type period with password and specify the password as the parameter. Then call period build and finish the statement with a semicolon. Almost there, we just need to make sure that our database actually starts. Let's do await database container period start async. Now, this is an SQL server, so I should be able to get a connection string out of it, right? Yep, just type database container, get connection string, and you can also print it out so we are able to see how it looks like. Great. That's the whole method for now. Let's do another one where we will just clean up the containers after use. Let's do public static async task class cleanup and make sure to annotate it with class cleanup attribute, which will again only run once after all the tasks are done. And inside this method, all we need to do is call await database container stop async. Great. Now let's write a dummy unit test just to see if we did everything correctly. This one can be a class method, so just type public void test SQL server connection and annotate it with test method. This will allow you to run the test. Then connect to the SQL server as you would normally do. Using then inside var db connection equals new SQL connection, and then get the connection string from the container. Then inside the method called db connection period open, and let's write our first assert. So assert is true that db connection period state is equal to open. Otherwise, let's return an error message saying that our connection failed. Halfway there, let's test this out now. Set a breakpoint inside the class initialize and then debug the test. If you see this right after you start the test, this means that your Docker engine is not really running. Let's fix that by opening Docker Desktop from the start menu. Now, the first time you run the test, it will take quite some time for Docker to download the SQL Server image and make everything ready. But every subsequent run will be much faster. If you're interested in what's happening behind the scenes, open Docker Desktop. You'll see that test containers first start up their own container, and after some more waiting, you'll see your brand new SQL server. Ta-da! I was so happy when I first saw this. And Visual Studio is happy too. It stopped at the console right. And now I can check the connection string. Just hover over the variable, then click on the little view button, and you should see the thing. Yay! Now let's see how this looks like in SSMS. For the server name, enter 127 period, and then all the numbers until the first semicolon. Yes, including the database port if you were wondering. For the authentication, select SQL authentication, then enter SA into the login field and paste the password from the connection string. Make sure to tick the Trust Server certificate and click Connect. Just a note, if you specify a custom port, there is a slight chance that custom port won't work with SSMS. Make sure to use what VS prints out in the connection string. Oh, and do you see this little penguin at the top of the screen? Yep, your SQL server is actually running on Linux. Oh yeah, baby. Now, there's nothing in my database at the moment and I want to fix that. I want to make this as easy as possible and I want to bootstrap my database with SQL code, possibly something exported so that I don't need to write my own code. And that's exactly what I'm gonna do. I will open up my production database where my script is running, right-click on it and select Generate Scripts. Select all the components that your app needs to run. If you want to include the data as well, click on the Advanced in the last step, then scroll down to where it says Schema Only and change that to Schema and Data. But that's optional, of course. And make sure to change the database type to Standalone Instance and select SQL version 2019. Maybe today, when you're watching this video, test containers have already updated the database version to something else, and you can actually check that by running your test again and checking what Docker says. On the home page, it will say which image you have, and you can also change this by specifying an exact image to use when building the MS SQL container. Now you want to save this script that's being generated as an SQL file. When you have it ready, go back to Visual Studio and create a new folder within your project. Name this folder SQL with all caps, then drag and drop your SQL file inside that folder. Now right-click on it and select Properties. And where it says Copy to Output Directory, change that to Copy Always. Then go back to your test file and add a new string field called Local SQL File Path. Set this to the location of the SQL file you've just created. You can do that dynamically by using the getCurrentDirectory and the path.combine method. In my screenshot, the last parameter is bootstrap.sql, but make sure to change that to match your script name in the SQL folder. And what will we do with this script? We'll copy it into the container and execute it with the database. It will be like running it with SSMS, but completely automatically, so you won't have to deal with it every single time. First, I just want to add another field which will tell Docker where to place my migrations file. I'll name this container SQL file path and I will set this to temp folder, like this. This is Linux, remember, so I'm using forward slashes here. Another field I want to add is the SA user password, and I also change that down in the code. And the last thing I want to add is a placeholder for my actual connection string. You'll see why just in a second, but for now just add it like that. Great. Now over to the class initialize. I will add one more option to my MS SQL builder, and this will be with bind mount. This will mount or copy the file to the container and make it ready to use. Perfect. Now I'll add a method which will actually execute this file. Private static async task execute SQL script async. It will take in the container and the path of the file. Inside the container, there's a command line tool that executes SQL files for me, and it's the easiest way to execute the files. The tool is called SQL CMD. The full command is here. So the tool is located in opt MS SQL tools bin folder, and I want to specify the server location with the -s flag. Next, I'll specify the username, which will be SA, and the password. That's why I stored it as a field. And the last flag, this -i, tells the command where I have the file stored. Great, now I will use the exec async function to execute this. This exec async is like running docker exec, but it abstracts away every detail, so you just run the function. Lastly, I want to check if the command ran successfully, and that's by checking the exit code. In Linux, exit code 0 means success, so I will check for that. If it's not 0, I'll just throw an exception. Perfect. Now let's use this method. I'll go back to the class initialize and call it. Almost there. One more thing, inside the migrations file, you've probably created a database. The default connection string that this method returns points the SQL client to the master database, but you want to change that to the database that you've just created. So I'll create another method which reads the connection string and changes the database property to your own database. And finally, let's use this method to set the global connection string like this. And done. Finally, I can finally start writing some useful stuff. This was a bit of a burden, but you can now reuse this logic in every test. Whenever you need a database, you can use the same setup procedure and it'll just work. So consider it as an investment. And now I can finally run my program. I'll call the run method from my program.cs file and pass the right connection string as the parameter. After the script runs, I want to check some values in the database. I can simply use the usual way of reading the values from the database, and if you're using Entity Framework, you can use that. It doesn't really matter because this is a real database now. And finally, let me write some asserts like that. And I am done. My first E2E test is done. I know this was a lengthy procedure, but I truly hope you saw value in this. Now, whenever you implement a new feature, you will have some tests to rely upon. No manual testing, just run the script and C# will do the rest for you. But that's all for today. Make sure to like and subscribe, and see you in the next one. Cheers, bye.